Okay, so I'm going to go over a few key things as far as the identifying reactions go. Okay, so we did our demonstrations. We talked about what type of reaction they were. We wrote out equations for them, and you guys did a great job with that. Okay, the part that we seem to be struggling with a little bit is the particulate diagrams. So what I'm going to do is I'm going to present to you the starting part of this so that you can try to figure out how to do the second part of it. Okay, so for instance, on here, here's number one, that was the ice melting. So I'm giving you the starting part of it, and I want you to figure out what you would do after that. What would that particulate diagram look like on the second part of that? Then here's water boiling. So I'm giving you the starting point. What does it look like as it moves from liquid to gas phase? Here's another one. There's still wool. So think about what happens, and there is a reason why I have three oxygens. It is diatomic, and then the blue represents the iron. So how would you draw that on the other side with that reaction? Here's baking soda, and so I got you started. What does it look like as it decomposes? What is it breaking down into? Okay, here's dry ice. Again, it's a solid, it's sublime, so it skips liquid phase, goes into gas. How would you draw that? Here's the copper chloride reaction. I have the two vials with the substances in each one. They are color coded. Hopefully you recognize that that is your oxygen. I'm sorry, that is your water molecule. All right. And there's a reason why I have these as they are. Okay. Pay attention to the numbers that you have. So when I put those two together, what does it look like over here? And then 7 we already did together. Okay. Then the last part, part 2, we have the reactions. And again, we're working on the spectator ion aspect of it. So remember, if it stays the same state, it's the spectator ion. We mark those out, and then we get our overall reaction. Okay? Then you need to describe the process that happened. I'm not going to put a description on most of these because you've already done these before somewhere along the road. Okay? So this one here, because everybody's getting a different partner, there is no net equation because everybody's changing in this. All right? I will help you on this one that we get a yellowish solid that appears. That is the I2. Physical change. We did this one in class, chemical change, and we looked at the fact that this is an H on the front, OH on the back side here, so I have an acid base. When I see acid-base reactions, the way that I can see those is using pH paper indicator or a pH probe in order to see the changes. Otherwise, it's a colorless solution. Now, this one here, we've done this one, magnesium ribbon with the oxygen making magnesium oxide. Since each one of those changes along the way, there's no net ionic equation. But on this one, I do want you to draw what does it look like before, what does it look like after. So practice that particulate diagram. I think you can do just fine on that. Then 6, we have sodium chloride with a silver nitrate, another reaction that you've done before. I've circled my spectator ions for you. So we take those out and we get this for my overall reaction. There is a precipitate that forms, that is the silver chloride, and it is a white precipitate. I'll leave this one for you. Again, think about this one, probably a physical change. I'm going from gas to aqueous. I want you to draw what that looks like. 8, again, sodium and sodium, both have the same charge as they go from left to right. So I write out my net equation with what's left over, and then I can talk about this reaction because I have a gas here, so gas bubbles are being given off, and that's my indicator the reaction has occurred. Here we have lead, nitrate, and sodium. The nitrate, it's a spectator ion, it's always aqueous. and then sodium in same position. So there's my net ionic equation, and PBI forms a yellow solid precipitate. And the last one, okay, you may not recognize this one from the start, but if you look here, I've got a hydroxide. That's a base. So as soon as I see that, I'm checking here. Yep, I've got an H in the front, so it's acid-base reaction. So again, I'm back to my pH idea that I need pH paper, litmus paper, or an indicator in order to know if that reaction occurs. So I hope that helps. Live long and prosper.